So welcome you all guys to debugging doubts. Now in the previous video I have showed how to solve the Prim's algorithm and Kruskal's algorithm, but in this video I am going to show how to use the table and solve it during the exams. So for the Kruskal algorithm, so there are two rows, one is heads, one is weight. So the number of columns are number of edges we have. So here totally we have 10 edges. So I made 10 boxes for that. So now let's go one by one. So first edge I will select is the minimum. So I will select in that ascending order. So minimum is BC. You can see it has the value of 1. So I'll choose that BC and weight is 1. Next weight is C 2. FE is small. So FE. I should sort it first. Then next is 3. You can see AB. So I'll choose AB. Then next is 4 and 4. I can choose any order. So I'll choose BF first. So BF has 4 and CF has 4. Then one more I can choose any order. So AF has 5 and FD has 5. Then AE has 6 and CD has 6 and which is ED has 8. So 10 edges are done. Now I'll construct the tree. So first is BC. So I'll draw it as while referring this tree. So B to C and value is 1. Next is FE. So here it is somewhere, right? EF. Then here it is E. So value is 2. Next is AB. So A is here. So A to B is 3. Next is BF. So B to F. Value is 4. Then CF. CF I can't do because if I do it will be form a cycle. So leave this. Then AF. So AF also will lead to cycle. Leave this. Then FD. So F then D. So it will be somewhere here D and value is 5. Then AE. AE also leads to cycle. Then CD. CD also leads to cycle and ED. ED also leads to cycle. So leave this. So this is my final minimum spanning tree. Let's solve using the Prim's algorithm. In the Prim's algorithm, so any algorithm may be, first we need to remove all the self loops, and second point is we need to eliminate all the double or triple edges between the same 2 points. That too we must remove in every Kruskal algorithm, Prim's algorithm or any other algorithm. Now in Prim's algorithm, first what we do is we count the number of vertices. So there are 6 vertices, so I made 6 cross 6 matrix. So this is from and this is true. So from A to A is 0. So B to B is 0. So vertex self loop is 0. So I am writing all as 0. So all the diagonal as 0. Okay. Now let's see the values. From A to B, what is the weight? From A to B, it is 3. So write it as 3 and same as B to A is also 3. Then A to C. So A to C. I can't reach C. So I'll write it as infinity and here also infinity. Then A to D. A to D also not reachable. Infinity, infinity. Then A to E. A to E is also reachable. So it is 6 and here also 6. Then A to F. A to F is 5. Then here also 5. Now do for B. So B to C. So B to C is 1 and here also 1. C to B is also 1. Reverse is also 1. So then C to B to D. B to D is not reachable, infinity, and D to B is also infinity. Then B to E. B to E is not reachable, infinity, and here also infinity. Then from B to F. B to F is 4 and here also 4. Next let's see C to D. C to D is 6. Then here also 6. Then C to E. So C to E is infinity. Here also infinity. Then C to F. C to F is 4. And F to C is also 4. Then D to E. D to E is 8. Then E to D is also 8. D to F is 5. And F to D is 5. And E to F is 2. And F to E is also 2. And hence we have solved the table. Now think we need to draw the minimum spanning tree. For that purpose, first I will start from A vertex. So I'll select A and I'll draw it here somewhere referring to this same graph. So write it as A. Now from A, I'm seeing in the A row, I'm seeing which is minimum 3, 6, 5. Which is minimum 3. So which is that to B. So A to B. So I need to draw A to B and value is 3. Okay. Now what I do is I have selected A and B, right? So I'll tick mark in that box. So A to B and B to A. Okay. So now I'll see in A and B. In both the rows, I'll see which is minimum, which is not ticked. So you can see 1, 4, 6, 5. So 1 is minimum. So I will choose that. So that is where B to C. So I'll write B to C as 1. Now C is also included. So tick mark this. Okay. Now C is also included. So I will now check A, B and C. In these 3 rows, I'll check which is the minimum. You can see 4 and here also 4 is minimum. So I can choose any 4 whichever I want. So I'll choose this one B, F. So this will be here F and this is 4. So tick mark that and FP also here. Tick mark this. So these 2 are there. So now I'll check in the A, B, C and F row because we have that 4 node as connected. Now in this row I'm checking which is minimum. You can see 6, 5 and here 6 and here 4, 5, 2. So 2 is minimum. So which is at F to E. So from F to E I'll draw edge and that marked as 2. Then tick mark this both E to F and F to E. Okay. Now E is included. So I'll check in the E also. So now you can see 6, 8, 4, 5, then 6, 6, 5, which is minimum. So I can see 4 is the minimum. So if I choose 4, F to C, it will form a cycle. So discard that value. F to C and C to F. Now we'll see which is the minimum. 6, 5, 6, then 8, 6, 5, 5. 5 is the minimum. So FA also can't be done. Discard that. Then FD 5. Yeah, that is valid. So I do F to D as 5 and this value I'll put tick mark. So almost all the edges are done and all the edges are connected and this is the minimum spanning tree. Even in this we are getting the same thing. Sometimes when you solve using Kruskal and Prim's algorithm, you may get some different variety of graph. So that does not depend on anything, it's just the algorithm. And this was all for today, and thank you all guys for watching my video. If you like, please like it, share it and subscribe it for more videos. Thank you all guys for watching.